Y para continuar, empezaremos con nuestro presentador internacional de la noche, el doctor Filippo Mazza, Researcher en Data Science, Machine Learning y Big Data para negocios, quien será nuestro expositor de la noche.
El doctor Filippo Mazza nos expondrá sobre Big Data, Big Problems in Practice, desde Múnich, Alemania. Esperamos que la presentación y el tema sean de su agrado.
Hello, hi everyone, I'm Dr. Filippo Mazza. I'm sorry if I'm not there physically or was able to make a live video. I live in Germany, with the time zone it was not possible, but I'm hoping that today we can see anyway the big data details I wanted to share with you with a presentation called the Big Data, Big Troubles in Practice. Question mark, why? I think that some elements that are here would help understanding the complexities in practice, especially, but also allowing to understand that these complexities really depend on what you need to do, and seeing some things in practice can help demystifying this concept that sometimes is a little fuzzy. Just a disclaimer, I work for Huawei Technologies in Germany. However, all the elements and opinions that I express here are just personal. I'm showing you my personal views or experiences, and not necessarily the one from anyone else, an organization or committee, just for understanding together some elements. And I think that this is valuable, especially when you're starting in a career that could bring you to work on big data one day. So what I wanted to see today is that big data is, while it's fuzzy somehow, it is a need for many companies and must be addressed. So as there is a lot of theory out there, it can be not clear what is really big data. So we're going to translate some of these theory requirements in practice. And we'll do this thanks also to some use cases with some details, and then a little bit of infrastructure that is behind to really construct the big data pipelines. Today with the cloud is much easier than before. For this, we're going to have a little bit of practice with a real cluster on, let's say, a simple demo for text analysis, and then we're going to draw some conclusions. Okay, let me turn off the camera before we continue. I'm still here, it's just that otherwise we don't see the slides. Okay, so the first part I wanted to address is the need of big data, because a lot of companies and the market in general can find really a lot of value, but unfortunately they don't know how, because many times it's really fuzzy, as I said. The point to understand is that modern times require big data. This is clear. More and more we have a huge amount of information and more forms of communication nowadays that completely changed how we need to store and process the data we have. If you have a look at the big data topic across time, the last 10 years or so, you had a huge increase in the search trend. And this is not just a fancy thing, but actually a need. The business operations need to deal with this amount of data, especially if you're in an informatic company, I'll say. Sometimes you also have legal obligations because you need to keep the data for security purposes. And then, of course, you have machine learning that uses big data for recommendation, for our features, and many more tasks, of course. I think that big data, exactly because of this need and trend, has been hyped very heavily. And this created a bad effect, I think, that actually made the companies believe that this can bring more value than it actually can. Marketing followed this trend, and it became a buzzword, sometimes misused. External companies that provide services can leverage this and provide high value services. However, sometimes maybe these are inflated. And in any case, there's a lot of theory behind that is quite important. However, it has been also exploited for creating the buzzword that we know today. We see everywhere 3V, 4V, sometimes 8V as a description and so on. And sometimes they make it more complex than it actually is, depending on what you need to do. And this is what I wanted to underline. So the fact is, companies today struggle to use big data or actually even approach the problem. Many times you find companies working in Excel with big data, or at least this is what they think. And so that's why I made the small meme on the side. I hope you know memes. And I think it really underlines the issue. This is a struggle that companies today have. A large part is due to the mystification that I said before, but is also sometimes true to real complex issues, costs. The fact that the transformation requires a completely shift in the corporate mindset. They don't even know sometimes if it gives value for their current market. Maybe some management thinks that they don't need it in the end. And even if they have, sometimes they don't know how to extract the value. So the real question is the big data approach valuable for companies, even if they don't know? But technically, is how do we do it? Because once we do it and have a preliminary data to work with, maybe we can understand if there is this value or not. So now, with this in mind, what do I do is more clear. So I actually design and implement big data machine learning solutions and making research so that I transform most of this requirement into real production pipelines, for example, data analysis, data extraction, and then finally machine learning in real solutions. Here's a QR code for my LinkedIn profile. Feel free to add me. And if you have any question for the presentation, please don't hesitate to write me. Now, I'd like to discuss some details for the requirements in practice. What's interesting to see is that even today, one of the searches that have been done on big data is how big is big data actually. That can give you a large amount of results, in my opinion, considering that today is quite understood. And what's interesting is also that depending on when the answer was published, you will see different results. And this is because the big data concept also changes with time. Another thing that evolved with time is the theory that made this big data more abstract and easy to understand from a management level, because they started from different keywords, three keywords especially starting with letter V, like volume and variety and value, and then increase to 4, then more, and then now, to my surprise, we get up to 8. So basically the concepts that are around big data are the ones that I show there, like for example volume, of course, let's say, the variety, otherwise any data source, let's say, it's useless. The value, that's what it gives, also the variety. It depends, however, on how you use it. Then you have velocity, because the data arrives at a speed that makes you process it in one machine unfeasible, so you need more machines to process one element of data before the next one arrives, for example. Then there are other like veracity, but whether it depends on the quality and source. Plus, there are also nowadays words that maybe are more related to how you use the data science, and the message that you get from it, like keywords like visualization, virality, and viscosity, and what's more. This theory, while very useful for some aspects, also created some fuzziness around, and some common ideas have been started popping out from companies, especially like the need to process the data very fast, which could be in line with some processes, but also some other ideas like with the powerful machines needed for the process that then transforms into a high cost and high complexity to start, or difficult to maintain systems, or maybe just the need of big data for machine learning. But the reality is that most of these elements depend on the use case you really need to have. And still, while it's not easy as on pure theory, you can start in a simple way, and you will see that later in the cloud with the demo. However, the value can be marginal if you don't have the ideas that you want to get out from the big data. Even if you have the power, but you don't know how to process it, then that's no worth. So let's translate in practice the words that we've seen before, at least some of them, to have a little bit better understanding of what we're talking about. So companies agree that when we talk about volume, they can underline that the amount of data is more on the petabytes of data, so that you can imagine you cannot fit any hard drive you can think of, or any memory as well. You have, in terms of variety, hundreds of different data formats that could require different pipelines and different data processing. Regarding the value, well, you have one value that is the one produced by the data, but you also have the one that your data processing costs. And we're talking about thousands of dollars per month approximately for some costs, but it can produce millions of dollars per year, especially in big companies, if you know how to use the data. In terms of velocity, we're talking more on gigabytes per hour or hundreds of units per second. And focusing on another aspect like the visualization, you will see that in practice you need dashboards with some approximation and aggregations, especially for the metrics associated to the big data itself. Let's see some use cases from famous companies. Walmart, for example, was focused on the need of having right products at the right place and right time, and these for competitiveness reasons. However, technical challenges are related to the real-time transactional databases having around 40 petabytes of data, and now this has been transferred to Hadoop, that is a distributed file system for big data. And the problem was to find the right people with the right skills to address all this data and pipelines. Netflix, the famous media service provider, had problems with the collection that they have. They use big data for analytics and recommendation engines, of course, but their collection is huge. They have, at that time, they had 3 petabytes of data. Today is probably even more, with many different data formats. Before they were using Oracle database, then NoSQL approaches, then Hadoop again, or Hive in Amazon AWS services. The problem is that a lot of valuable data there was stored in a messy, unstructured content, and this is a challenge in big data. That's why probably they had different formats evolving with time to address these issues. These and more, probably. Airbnb also uses, of course, big data to connect guests and houses. They have technical problems related to the amount of data that is 1.5 gigabytes approximately in clusters, again, on Amazon machines. And the problem was to allow the people to work on all this. Another use case example that I want to mention is the one from my previous employer, Sparklane, addresses big data and machine learning for business to business. It's a French company that makes a product that helps identifying the best customers and to target at the right time. There's, as you can imagine, big data behind, especially to gather the information regarding millions of French and United Kingdom companies, with not only firmographics data, so turnover, number of employees, and so on, but also the news appearing on the press regarding these companies. And behind there is machine learning that proposes the best customers at the right time. They have a web application that is their product, which provides the most important customers at a given moment, and you can score them, you can select some criteria, you can set it up in order to get the information you need. And as you can imagine, each of these components has behind a specific pipeline to retrieve the data. And one pipeline that could be simplified is the one as such, in which you have multiple components accessing cloud services, each of them in a small machine in the end, to get a specific element and to process it, and then input these elements in the next step of the chain and in the product that you see. So you have different components in different languages, like Java processing the customer data and then merging it with the distributed cloud data storage that has the data of the companies. Then there is multiple workers in Python for data process that, as you can imagine, remove data problems, missing values, some cleaning is needed, because then we show this data to the customer, but we also have machine learning processes that with multiple machines, once again, through APIs, provide the data to the final interface. Now that we have a little bit more elements in practice, we see that big data is more big challenges. Actually, many challenges that should raise many questions. For example, regarding the velocity, do we really need to process all the data fast, or we can have different speed and different quality of service? Can we skip some computations? Is the data rate constant, or can I be allowed to have some delays? The scalability also, the volume can change with time, so we need to be able to adjust the system. Reliability is another important challenge. What if a machine crashes during the task? Maybe it's better to have many smaller machines with the price of a higher price to pay in the intercommunication challenges, because there are many moving parts, more than having big machines that are more costly, that are not the ultimate solution if they crash, and have maybe smarter algorithms instead. So what I wanted to say is that big problems can be solved with small solutions. A nice example, I think, it's the use case of eating a huge cake. Some questions you can ask yourself is, should I do that in a single day, or can I use a freezer and eat it another moment? Should I eat it all alone? Or another question is, do you eat alone, so in one piece, or can I cut it in smaller pieces and have it at different moments? By the way, another question is, where is the cake is actually? It's important. This translates in big data approach and different questions, and they actually make sense with the same concept of big problems with small solutions. So how fast do you need to consume this data? That's important. And especially how many workers, so machines, do you need to process this data? Also, do you need a big fridge for the cake, or many small ones make a difference? And the same is for big data, if you need a big storage, or you can use distributed ones, especially because you should avoid moving big data, but bring the computation to the data. So this brings us to another important component in big data, that is the infrastructure. The big data problem or challenges actually then end in another component also, that is the infrastructure. So where the big data pipelines are created. The big data is not hard only for the large data, but it reflects everywhere on the design, realization, and maintenance of all the components that created the real data processing. As you can imagine before, in the example I made for Spark Lane, there's plenty of moving parts, and these have each one has different challenges, and the orchestration of all these moving parts is even more challenging. As one element that I want to convey here is that there's a big overhead involved with the processing itself. Just to make the, for example, machine learning task, there's plenty of different other tasks that need to be considered that have much less to do with the real data, but with the processing and resource management and infrastructure. And this is the same for big data. There's a nice paper from Google that I referenced here at the bottom that explains this hidden depth, as they call it, for machine learning. But I think that the concept translates well to big data as well. Another important element with the infrastructure challenges is the cloud, because it makes big data somehow as a puzzle where you can find different readily available pipeline elements online in the cloud provider that allows for very easy solutions that relatively, with a relative ease, you can make a complex work, and you can lower the costs. These are semi-automatic systems. You can find multiple clouds online. Every has different aspects, or whether they share commonalities, especially regarding the services that they provide, or whether using the cloud is not always feasible, because in some cases the data is sensitive and must stay in your company. There's privacy and security issues related that forces you for an on-premise server, and you cannot export the data on the cloud. Very often online you find big data pipelines related to theory in a very colorful and fuzzy way, like this one, even though they are very useful for summarization. Actually, in practice, must be translated in a much more complicated way, where the cloud services are multiple and need to cooperate together in order to finally perform the tasks that you need to use. Let's see a big data task in practice with a small demo. I decided to make it in the cloud of Google because it's very simple to do. You can already use it from Panama. Some companies use the cloud from Google there, and you can replicate. However, be careful because there are some costs involved, even though small. We're gonna show them later, and you need a little bit of attention when you deal with this. We're gonna work with Python, and we're gonna then have a small task that is as such, where we need to make some web text analysis. So we need to analyze the text from a large number of websites to have an understanding of the most important words per website. So the hypothesis that I set is that we have already a tool giving us the web pages. This is another element of the pipeline that we will not see. Maybe we can make a presentation another day. But basically what does is just retrieves the data and saves it in a cloud storage. I selected the Google Cloud Storage because it's the one from Google here in the cloud. So each website can have tens of pages with kilobytes of text in each one. One website, as you can imagine, is not a problem, but if you need to treat 1 million of pages, that could start to be a problem. The pages now I already processed them to merge them in one file with one page of text after the other. So this is not a big deal. We will make the analysis only on one website to make the example, even though if it's a big data pipeline, we can use it for one, and we're going to use the one from your university, USMA. So the subtask that we need to do on this element is to count the word frequencies for each website, and then get the most common ones. And let's see if it's really so complex and costly. As I said before, one machine, even if it's big, is not the solution. It's inefficient. If it breaks, the business is down, and maybe with more data coming, it will not be enough soon. So the solution is to use many machines which provide high availability. Even if one breaks, the other one will perform the task. It's customizable. It's even easy to replace. As I said, we can scale up or down the number of machines depending on what we need to do. However, this comes with the price of a harder orchestration because we have many services that need to communicate and we need to manage the data. For this, we will use big data software, open source, big data distributed system management tool that will perform the processing for us. So the idea behind is that we need to distribute the data and the work on the worker nodes so that each one takes a piece of the cake and performs the operation that we need to do on the data. We have already the data in the cloud. I already put it for you in the Google Cloud Storage. Someone can use also another system that is Hadoop. The difference now, it's not important for us, but what's important is that the data will be in a distributed system. Different parts of the data will be given to different workers, and the task that we need to do, we're gonna give it to each worker. So each worker receives the task to do, and we're gonna reduce map and reduce the tasks. So map each task to each piece of the cake, then get the results back from each one, aggregate them, and get the solution. This has the advantage that if you need to make it faster or you need to process more data, then you can just add the worker nodes and distribute even more your task. Coming back to the pipeline, below you can see the services from the Google Cloud that we will use, especially the cloud storage for stored data, the data processing service to launch the Spark, and then somehow the Colab, actually we're going to use Jupyter inside the different machines. That is software to visualize, so to have a web interface to run the data as if we were there on a shell, Python shell, so that we can run the Python code and get the results. And now we can see how to do that in practice. Just a small in detail more before we start. This is the configuration that I will use. I want a master node that will manage the different workers, which will access the Google Cloud storage to get one piece of the data. And then through Jupyter, we're going to run Python code, which goes through the master on the workers so that each worker can perform one computation and then give back the result to the master. If you do this, just a disclaimer, be careful because we're working with real infrastructure which has an associated cost. And if you make an error in the configuration, it can be quite costly, but we will see. Okay, then enough with the talk. Let's start with the demo. So to do that, we can go into the Google Cloud. Gonna access the control panel here. You need to make your login here that I already done, and then access your console. So here we have all the services of Google from the cloud platform. Here you can see your status, your monitoring, your resources, and so on. So on the left, you can have all the services that you're using frequently, as well as all the services that are provided in general. So the compute engine, the cloud functions, everything that need to run like a single function on the cloud, or your storage, big table, data store, SQL databases, and what's more. We will also see here the storage. That is the storage service from Google Cloud, where I already saved some data to play with. Now we can go back and focus on the big data tools for computation. So in particular, we're going to use the data processing tool, where we can create our clusters. We have no cluster now, so we need to create one. And we're going to create the cluster, as I said before, in the slides, as here. So what we want is a master node with 3 workers and Jupyter on top. So we're going to go and create the cluster. We're going to have many different options. Okay, the first one is a name. Let's say USMA test. Doesn't really matter where geographically is located the cluster for our exercise. That doesn't matter right now, but this is something important when you need some data in a specific location for accessibility purposes, so that it's easier to access for your users. And we're gonna go with the standard mode with 1 master and workers, as we said. So the master one, you can choose the machine. We can select how many CPUs, how much memory, which type of machine. We can go for a different type of or families. We can select, as I said, different configurations for different loads that we need to address. We're going to go with the standard one, a simple one. You can also select the disk size, but we don't need it. So this is the local hard drive, but we're going to use the general distributed file system that we will see later. This is the worker nodes that we also can select, where we can select the machine, the same as the master node. And we said that we want 3 nodes, so a total of 12 cores for our distributed task, 3 machines having 4 cores each. And we need some components on top, so access, we need to access from the web, and we need also in the other configurations, there's a lot, but we don't need all of them now. There are some encryption options and so what's more. What we also have that is important, delete the cluster after your task. And it would be nice to have it delete automatically after 2 hours, so we don't incur on other costs. One more step, we need to select the Anaconda Python distribution package manager, because we want to work on Anaconda on Python, and we need the Jupyter notebook, as I said before. So everything should be set up. Let's start the creation of the cluster. So now Google Cloud is provisioning our requirements and our machines, and we will see them in a few minutes. I'm gonna pause here so we don't lose time idle. So now the cluster has been provided, and as you can see, it's up and running. Let's click on the new cluster and we can access the details. So there is a main screen here where we can see when we can monitor the memory, the HDFS capacity, CPU utilization, and what's more. You can see if there is any job running. Not yet anyone, of course. There's no job running yet. You can edit the configuration, but with some configuration. And then here you have your web interfaces that are the ones that we actually want for specifically use the cluster. And we're going to use Jupyter Lab, as I was saying. So, okay, we accepted the redirection. So we're going to connect to the machine. And here it is, the interface of Jupyter, that it's, as I said, the interface to work with the cluster as if we were running a Python job on the terminal. I'm gonna go into the Google Cloud Services, where I already loaded the needed code. So here we're gonna use Spark, that is our distributed framework for parallelizing the tasks, and we're gonna start with a simple example. So we're gonna use Spark. We don't have to go into the details now, but we're gonna use Spark to parallelize our data that we want to perform an operation onto each element, and this is the operation. We want to multiply each element of the array by 2 in a distributed fashion. So now what we can do is to map the operation. We'll write a function that does the operation, and we're gonna map this function over each element of this array to then collect the results. So you can see this that has been done very fast, has been sent to the executors and then computed the operation on each single element and sent it back. Actually, we can make another step before to show you some more detail. So when we get parallelized array can also access one single element, that is this one, and then this operation can be added on top of each element as such. So I can also stack more operations one after the other, or write more complex function here to perform more operations if needed. But now we can see that with a real task that we actually need to perform on the data of the websites. And we're going to do that on the data that I already loaded into the distributed file system. As I said, I'm going to use Google Cloud Storage, so I'm going to access it here. And we are going to get the data from the so now we're going to perform the real task that we need to do on the website data. So now we're going to perform the real task that we have to carry on the website's data. And the data I already loaded in the Google Cloud Storage in one bucket that we saw before. And we basically read from Spark. With Spark, we read the distributed data in the big data storage that we have as a CSV file. And we're gonna get, what we get is a set of rows that are in the PySpark format. That is the one that is read by the system. So as you see now, it was very fast reading it. Okay, you see only one row of the data, so there is something called lazy evaluation. So basically, it didn't read all the data; it just got the first one, and then what is going to be performed will be performed on the whole dataset. But there is no need to load it all at once right now. The data is distributed, so we're going to map one operation. The first one is to get one element from each chunk of data and join them together to get the full sentence. This is due to the fact that I loaded in different tasks, and then each task has one element of data. So what we want to do here now is to have the full sentence. And we're gonna, it's not really important for the final result, but we need to merge the different parts. And to do that, we're gonna go towards a data frame that is distributed so that we get one piece and we map the operation as we did before, basically. Just that now we do that with the real data, so we need to step more. That is the one you see here. So that basically takes the different pieces of data that here we see 1, 2, and 3 from your website, and we load it here. There are some small data issues for the format that right now we don't really care about, but it's due probably to the encoding because of the accents and so on. But right now, let's say that it's fine for this step. So now we have only the USMA, but what if we had many more websites? Well, we should group the data for each website by the website it belongs to, right? So we want all the sentences from the website of USMA together so that we can run the analysis on top. And to do that, we can give a key to each of our element, being one element being as such, so that we know that it belongs to that website. Now it's easy because it's only one, but if we had many more, we should still be able to give a key to each element based on how we gather the data. Maybe the file name, maybe the time when we got it, or maybe the time and the URL and so on. So what we want at the end is just to get each element of the data and key each element by our function that returns a key. In this case, we already know it's this the key, so that at the end, each element that we have, so when I do like this, is running the code, again, is only on one element now, because it's not asked to be performed on everything, but I'm just asking the first element here. So you get, this is my key, and this is my value for this data element. Now we can write the function to process the text. Remember, we want the words, so we need to make a little bit of processing. And we want to run the processing on each of these elements in a distributed fashion. So to do this, we can write a function that processes one line. So for example, we need to remove the new lines, the symbols, split the line into words. Now I'm using a very simple approach of just removing the spaces and what's more. Then we need to maybe standardize the data and then return each word on the sentence. I'm removing the small characters that could be still there. There's plenty of other tasks maybe that we can do, but this is a preliminary example. And we need to process these sentences. And the sentences now are the keys, are the values of my key value pairs. So I'm gonna get my processed lines mapping my data values. So I'm gonna apply a mapping function. So I'm gonna map this function, that is this one. So I'm gonna map this one over the values. And for this, there is a specification called map values. And I'm gonna again retrieve the first element. So at the end, we're gonna get our key value pairs in key and format as such for the sentence. So the sentence is, as we wanted, split into different words. So it's a key value pair made by a key and array of words. Now we want all the words of our website. So we can do that thanks to the key that we had before. And for doing this, we just group by key. There could be some better way to do it, but I'm not going to go into the details. We just want to have all the words together. And there is a format internally that PySpark uses. It's an iterable of results. So basically, what it does is getting all the results and providing them in its internal format. So basically, what we have here is all the sentences of the website USMA in a parallelized way as a result internal format for PySpark. Now we know that all the sentences should be just gathered as I did here, and then count the words on each one. And this is our operation on one website that we want to do. So basically, we want to gather all the words for all the lines in my website data. So this is a Python class for counting the words and providing a histogram of elements. So basically, it gives you how many times each element of one array appears. And we're gonna just get from this histogram the most common 10 words. So this is the operation that we define. And we're gonna map this operation on each value of our key value pair. And we're gonna get the first one, that it's the USMA, because we have it. So as you can see now, the most important words in the text of USMA are these. Quite strange, isn't it? I mean, yeah, it could be, but it doesn't give you the information that we actually wanted. This is an example of having big data tools and good operations. It's just a part of it. We need to really understand the data. So let's make an improved version of it. What we see is that there are plenty of elements that in natural language processing are called stop words. They're words that are common in a language, but they don't really give you the meaning of the sentence, right? So this is a common problem, and there are common solutions for this. One common package in Python is this one, and we're just gonna load the data sets that are embedded in this package, and we're gonna load especially the one from Spanish. And once we have the Spanish stop words, we can just remove them with a better operation that we can run on the values, so that if the words are, if any word in my list is inside here, well, we're going to remove it. We can actually see which are these. And you can see this is a list that has already been created in the past by the authors of the package that is already known. So we're going to launch this operation, and we can see already that now the text makes much sense. And this is just one example. Okay, now let's stop our task. Now we can just go back to our cluster example. So I wanted to conclude the demo giving an example of the costs. So these are the pricings that I found from the official Google Cloud website. And we have the cost for the Dataproc service we used. It is approximately 12 cents of dollar. Because of the general Dataproc cost, there is 1 cent per each CPU for each hour. So these are the numbers that we have for CPU for the master, 3 nodes for CPU each one, total 12 CPUs. I consider a duration of maximum 1 hour. You can, it's a rough estimation, however, and that's what it gets up to. And then you need to consider also the machine's cost. You need to be careful because the Dataproc service is only to launch the services, but then you need to consider the real hardware behind that it's fired up in order to give you the service. So basically what you have is the big data service that runs on top of the machines, and you need to consider then the price of the service and the price of the machine. And here you have the 2 different costs. So to answer one common question regarding the data, if it is costly, it really depends on what you need to do. And if the size is big and we need to have a higher reliability, then it's of course more costly, but we also have to think about the performances that we want. In our examples, we had a small number of machines, but if you need to do tasks much faster because we have much more data, then you need to consider this into your equation. However, if you accept the task to be performed more slowly, then maybe you can afford cheaper machines. However, more machines that are less costly will perform maybe faster than bigger machines, but in a smaller number. So with all the services and all the hardware that you can consider and all the component combinations of them, it's not as easy as it seems to have an exact computation. But in practice, when you have some tasks, you can perform them on a smaller amount of data, and you can get some estimations. And especially you can always put some budgeting alerts in order to avoid nasty surprises at the end of the month. So we ended up our time. Let's draw some conclusions. We see that there's a lot of things to consider for the big data, even just for a small sample example. Is this all worth it? Yes, this is the common accepted answer because it potentially gives you a big value. And with big data and data science, maybe you can make big science in the sense that better applications for machine learning are possible. Note aside, yes, but it depends on what you're doing. We already said that. For example, now you can use fraud detection, recommendation engines, probably deep learning algorithms, and what's more. There's noisy data problem that can be dealt in some ways or completely ignored, depending on what is the real message you want to get from the data. And expect that, especially if the data is from user or from the web, and it is normal, so expect messy data. But however, all this complexity now is reduced by the cloud. So to answer the question, is it complex and costly? Well, it really depends. It also depends on what you need to do. So you're paying a price for hiding the intermediate steps that can be there. So you can reduce maybe the cost because many operations that were needed before now are taken care of automatically. And that's it. Thank you for listening. Thanks for the support and invitation from the USMA and the people that provided my images. Bye-bye.
Agradecemos al doctor Filippo por brindarnos esta exposición tan interesante. También nos gustaría agradecer a Red Bull, patrocinador plata del COINTEC 2020.